Okay, so let's have a look at some properties of the salts then. So why does sodium chloride have a high melting point? Well, if we look at the structure here, we can see that each positive ion is being attracted to a negative ion that's being attracted to another positive, that's being attracted to another negative, and so on. So each positive is surrounded by 6 negative ions, and each negative ion is surrounded by 6 positive ions. Okay, so there's lots of forces of attraction that need to be broken, and those forces of attraction, which are the ionic bond, they're very strong, so it requires a lot of energy to overcome that, and hence for them to melt. Why are they cubic? It's to do with the arrangement of these ions, the fact that you've got very structured arrangements, so you've got positive, negative, positive, negative, positive, negative, and they're all in rows and columns, and that's known as a lattice arrangement. And if they're very organised in that lattice, then they will always form crystal kind of structures in a cubic arrangement. As the salt crystals, they don't conduct electricity. They will do as a liquid, so if they're in solution or if they have been melted, but as a solid they won't conduct electricity. And to be able to explain why, we need to be able to understand what electricity is. So you need to think of electricity as the flow of charged particles. Now here we've got the charged particles because the salt is made up of ions, and ions are charged particles. But what we don't have is the capability for them to move. In the solid, they're all being attracted to each other and held quite strongly in that lattice arrangement. Okay, so because the ions can't move, the salt won't conduct electricity in this crystalline state or the solid state. However, if we look at question 23, it will conduct electricity when it's in solution or when it is molten. So if we look at this one here, this is a molten salt, and this is a salt that's dissolved in water. You can see the water molecules in the background there, and these ions have separated from each other. So unlike the solid sodium chloride down here, both of these situations where it's molten or when it's dissolved in water, the ions are free to move, and if they're free to move, they can carry that electric current around.